In this video, I'm going to look at reacting gases calculations, but these ones are all at RTP, room temperature and pressure. So just a reminder of the rule for gases at RTP: 1 mole of any gas at room temperature and pressure occupies a volume of 24 decimeters cubed. So that 24 dm cubed is what we call the molar gas volume. So here's the first question: what volume in decimeters cubed of carbon dioxide is formed at RTP from the complete decomposition of that many kilograms of calcium carbonate? There's the balanced equation, and we've got to give our final answer to 3 significant figures. If you want to have a go at this, just pause the video and then play on for the answers, otherwise keep watching. Okay, so the first thing we do is the same as in the reactant mass calculations. We find the moles of the known chemical. So calcium carbonate's our known chemical because we know we've got 2.6 kilograms of it. Just be careful with your units because moles are worked out using grams. So it's 2,600 divided by 100.1, the MR of calcium carbonate, and it's given that many moles. Step 2, we apply the mole ratio between the known and the unknown chemical. Carbon dioxide's the unknown chemical, so that's nice and easy, 1 to 1. So we're going to get the same number of moles of carbon dioxide formed. And then the final thing we do is answer the question. So in this case, it's what volume of CO2 is produced at RTP. We've got to give the answer in decimeters cubed. So volume of any gas at RTP is moles times 24. So that's the moles of CO2 times 24, 623 decimeters cubed to 3 significant figures. Here's the next one. So again, if you want to have a go at that, pause the video and then play on when you're ready for the answers. So iron's the known chemical in this one. We know we want to produce 1.2 tons of it. So the moles of iron, remember we've got to work in grams. So 1.2 times 10 to the 6 is 1.2 tons in grams. So we divide that by the MR, that many moles. And now the ratio step. So it's slightly awkward, this one, because I've got a 2 to 3 ratio. So the moles of CO needed is going to be 3 over 2 times the moles of iron. So that comes out at that many moles of CO. So the volume of carbon monoxide at RTP is going to be the moles times 24. So that many decimeters cubed, but the answer is required in meters cubed. So to convert decimeters cubed to meters cubed, we need to divide by 1,000. So the 3 significant figures, that's 774 meters cubed. So this is the final one. I've chosen a particularly awkward one for the final one, just to check you're absolutely fine with this method. So again, pause the video and then play on when you're ready for the answers. So step 1, we're going to calculate the moles of the known chemical, TNT, this stuff here. So we've got a kilogram, that's 1,000 grams, divided by its MR. So we've got that many moles of TNT that's been detonated. So the reason this one is awkward is because we're not asked about a specific gas, we're asked about just the gas in general. So we've got actually 3 gases produced by the detonation of the TNT. So the ratio of TNT to gas is actually 2 to 3 plus 5 plus 12, which is 2 to 20, which obviously can be simplified to 1 to 10. So for every mole of TNT that's detonated, we get 10 times as many moles of gas produced. So obviously that's 44.05 ... moles of gas. So the volume of gas at RTP is the moles times 24, and to the nearest whole number, that comes out at 1,057 decimeters cubed. So well done if you got that one right. That was a little bit tricky, that one. So like I did with the reactant mass video, we'll just finish with a summary of the steps. So the first thing we've done is calculated the moles of the known substance. Obviously that's the one that we had the mass for. Step 2, we apply the ratio between the known and the unknown to find the moles of the unknown. So obviously that's the gas in this case that we had to calculate the volume for. And then 3, just answer the question. So we just converted the moles to a volume at RTP, applying that molar gas volume rule, but remember to beware of your units, so they don't always necessarily want the final volume in decimeters cubed. So just be mindful of that.